Hi everybody, this is going to be a short video on balancing redox reactions in a basic solution. In class we went over overtly the details of how to balance a redox reaction that's done under acidic conditions, and the algorithm for doing it under basic conditions is pretty much the same. There's just an extra step or two, but I thought I'd show you one overtly here through a video. So let's get our title out of the way, and we're going to take a closer look at the overall reaction that I'm showing here, where we've got nitrite plus aluminum to make ammonia and AlO2 minus. So as with the first algorithm for acidic solutions, the first thing we need to do is go ahead and assign oxidation states so we can identify those things that change their oxidation states. I won't go through that in too much detail because you should be pretty good at that at this point. The nitrogen here is going to be +3, aluminum is 0, the nitrogen in ammonia is -3, and the aluminum here in the oxide compound is +3. So you can quite clearly see that the nitrogen is going to be getting reduced and the aluminum is going to be getting oxidized. So let's go ahead and play with those half reactions. Here's our reduction half reaction, and let's go ahead and balance that independently first. So we have NO2 negative going to form NH3. The nitrogens are all balanced, so we don't have to do anything for that, but we do need to get those oxygens balanced. So I'm going to go ahead and add 2 waters to the right plus 2 H2O. That takes care of my O's. And then I've got 4 and 3 hydrogens on the right, so I'm going to need to add 7 H pluses over here on the left. Now, I realize we're doing this under basic conditions, and so we're eventually going to have to get rid of that H plus and convert it or sort of titrate it over to a basic solution, but we're going to do that later. Then I need to balance my charge. On the right-hand side, you see we have no net charge. On the left-hand side, we have a net +6, so that means that I'm going to need to add 6 electrons to the left-hand side. Which makes sense because, again, this is a reduction reaction and we want to add electrons as reactants in our reduction. Okay, let's take a look at the oxidation half reaction. So Al going to form AlO2 negative. The aluminums are already balanced, and so the first thing we'll go after will be those oxygens. So I'm going to need to add 2 waters to the left, 2 H2O. Now I've got 4 H's on the left, none on the right, so I'm going to need to add 4 H plus on the right. And then as I look at my charges, I can see that I have no net charge on the left. I have a +3 net on the right, so I'm going to need to add 3 electrons to the right. Alright, so my half reactions are balanced. Now I need to go ahead and recombine them. And as I do that, I'm going to need to make sure that my electrons in the reduction cancel out with my electrons in the oxidation. So I'm going to need to take the oxidation and multiply it by 2. That way, this eventually will become 6 electrons, which will balance out with my 6 electrons in the reduction. Okay, so if you multiply everything in the oxidation by 2 and you go ahead and recombine our half reactions, what you're going to end up with is a net reaction that looks like this guy here. Now what I've done during this process is I've already canceled out identical compounds on both sides of the reaction arrow. So to the extent that I could eliminate H plus, I've already done so, and to the extent that I could eliminate water, H2O, I've also already done that. So this would be the balanced half reaction if we were doing it under acidic conditions. But we're not. We're doing it, as the title says up here, under basic conditions. So in order to fix that, I'm going to need to titrate this over to basic conditions. And what we do is we're going to add OH minus to both sides of the reaction to the same extent as there was a balance of H plus on the one side. That sounds kind of convoluted, but here's what we mean. You see we have an H plus here on the right hand side of the reaction. That's all the H plus that was left over after we did all the canceling. So I'm going to add to the right hand side 1 OH minus, 1 unit of base, and I'm going to add that same amount, 1 OH minus, to the left-hand side. So I have added as much OH minus to both sides of the reaction as I had H plus left over in the acidically balanced version of the equation. So then the net effect that has is I can combine the H plus and the OH minus on the right-hand side. That would come together to form water, so I can cancel out that water with one of the waters here on the left-hand side, turn that 2 into a 1, and then I've got my basic balanced version of this equation. 1 OH minus plus NO2 negative plus 1 water plus 2 aluminum to make ammonia plus 2 AlO2 negative. And I should just double check to make sure that everything works out, okay? I'll just check this really quickly in red. I have 2 aluminums on the left, 2 aluminums on the right. I have 1 nitrogen on the left, I have 1 nitrogen on the right. I have, let's see, I have 1, 3, 4 O's on the left. I have 2 times 2, 4 O's on the right. I have 1, 3 H's on the left. I have 3 H's on the right. And I have a net charge of -2 on the left and a net charge of -2 on the right. So everything balances out. I know that I've got this reaction correct. All right, so that is balancing redox reactions under basic conditions.